Hello students, welcome to Dr. Shourab's classes. So in this particular video we'll be solving the maths section of this JAM 2023 and this is question number 11. So let's see the question. It's given that let n be the sine of 1 upon n cube and bn be the sine of 1 upon n. For n belongs to the set of natural numbers, then we have this four options A where both the sequence that an and bn are convergent, the series is convergent, and in option B is an is convergent but bn is not convergent, C is an is not convergent, bn is convergent, and option D is both an and bn are not convergent. So let us take a sequence. Suppose Cn is a sequence, right? And let us take this as in this b Cn be equal to 1 by n. When we express it in form of a series, so summation of Cn is equal to summation of 1 upon n. Now what it will be? Is it divergent or convergent? So according to the p-test, we have that if the value of p is less than equal to 1, then the following series will be a divergent one. So here the value of n is 1, so this series will be a divergent. The sequence is this particular series Cn is a divergent. Now if I take limit n tends to infinity, right, and it is given as bn by cn. So bn and cn, if it is not equal to 0, then we can say that if it is not 0, then only we can say that bn and cn both are divergent, or it's not convergent, right? Okay, so let us check what it is. Bn is already given sine of 1 upon n, so we will be writing this as limit n tends to infinity sine of 1 upon n, cn is 1 upon n, right? So we can take 1 upon n as m, so then it will be, okay, let us write it in some another ink. So what it will be sine m, and it will be m. So here n tends to infinity, so 1 by n tends to 0, so 1 by n is m, so we have limit m tends to 0 sine of m by m, which is equal to 1. That is a non-zero number, is not equal to 0, right? So both bn and cn are divergent, which holds true in our case. So these are both bn and cn are divergent. So here you can see this options are there. So option A doesn't stand over here because it is given bn are convergent, and option B stands over here. So bn is not convergent in this case, and option D is also there, that bn is not convergent. So let us check with another sequence, that is an, right? So let us take another sequence as dn, which is given by as 1 upon n cube. So this is dn, right? So by saying through the p-test, you can easily see that this sequence is a convergent one. Why? Because p is, for p less than or equal to 1, it is divergent. For p greater than 1, it should be a convergent series, right? So if we take this series as in this manner, that limit n tends to infinity an by dn, and we will have over here that limit n tends to infinity sine of 1 upon n cube by 1 upon n. Let us take that in this manner, that it is sine of m by n, where m is 1 upon n cube and 1 upon n is tends to infinity, so n cube tends to infinity and 1 upon n cube tends to 0. So we have this limit m tends to 0 and this is 1, which is a non-zero. So obviously we can say that 1 by n cube is a convergent, this not divergent, or we can directly say it is a convergent one. Okay, so in our case the sequence an and dn both are convergent, but we have to find for an and bn. So bn is not convergent and an is convergent. So what is our final answer? That an is convergent and bn not convergent. So what will be the correct option? This option B is the correct one, as it states that we have this n is convergent but bn is not convergent. So the correct option for question 11 is option B. So that's all with the solution of this question number 11. So in the next lecture with another problem. Thanks for watching.